Hi guys, today we will be going through the mock paper that you have attempted on the 8th of August. So let's go through one question at a time. Alright, so for question 1, they state that the highest common factor of two 3-digit number is 144. The lowest common multiple of these two numbers is 4,320, and the question requires us to find the two numbers. So first, before we even do anything, let's break down 144 and 4,320 in its prime number. Alright, so by using the ladder method or otherwise, we would have 144 equals to 2 to the power of 4 times 3 to the power of 2. So how did I derive this? Let me write my working at the side. So 144, right off the bat, I know that it is divisible by 2, right? So I'll write 2 here. So 144 divided by 2, I will have 72. 72 is also an even number, so I can divide it by 2 again. Alright, and I would have 36. Okay, 36, again, I can divide it by 2, I have 18, which is also divisible by 2, I would have 9. So from here, 9 is no longer an even number, but I know that 9 is divisible by 3. Okay, so I'll divide 9 by 3, which would be left with 3. So 3 is already a prime number. This means that we have broken down 144 in its prime factors, which consist of 4 2's. So 2 multiplied by 2 multiplied by 2 multiplied by 2, you would have 2 to the power of 4. Okay, multiply by 3 multiplied by 3. So you would have 3 to the power of 2. And that is why 144 would equal to 2 to the power of 4 multiplied by 3 to the power of 2. Okay, we would break down 4,320 in its prime factor. Okay, and we would have 2 to the power of 5 multiplied by 3 to the power of 3 multiplied by 5. So how do we go about doing this? We would just repeat what we have done with 144. Okay, so next we want to take note of what consists of highest common factor and what consists of lowest common multiple. Let's work with lowest common multiple first. Alright, so to have a lowest common multiple, I need to ensure that both my number 1 and number 2 consist of both 2 to the power of 4 and 3 to the power of 2. So let me write down 2 to the power of 4 and 3 to the power of 2, 2 to the power of 4 and 3 to the power of 2. Okay, so 144 must be a factor for these two numbers. Okay, so now we have a foundation. Let's look at highest common multiple. Okay, so for highest common multiple, it would mean that at least one of the number has a factor 2 to the power of 5. Okay, so I can allocate the extra factor of 2 to any of my number. Okay, so let me just allocate it to my first number. Okay, so when I multiply by 2, my first number would have a factor of 2 to the power of 5. Okay, then let's move on to my second term, 3 to the power of 3. Okay, this would mean that at least one number should have a factor 3 to the power of 3. So at this point of time, both of my number only have a factor of 3 to the power of 2, which means that I need to multiply by 3 to any one of the number. Okay, so you could choose number 1 or number 2, that's up to you. Alright, so you would, in my choice, I would put it as a factor in my first number. Okay, then next let's look at the third term, 5. Okay, so this would mean that 5 needs to be a factor of at least one number. So I can choose to put 5 in as a factor of number 1 or number 2. But let's look back at the question. The question says 3-digit numbers, alright? So if I were to add my 5 to number 1, would both of my number be 3 digits? No, my first number would be much more than 3 digits. My first number will be a 4-digit number, which is 4,320. Okay, so I could not add my 5 here. I can only add my factor 5 to number 2. Okay, so when I equate these two numbers, my two numbers would be 720 and 864, which is my answer for part A. Let's continue with the second part of the question. The second part of the question says that a number x is divisible by the number 2, 3, 4, 5, 8, and 9, but leaves a remainder of 5 when divided by 7. So find the smallest possible value of x. So straight off my mind, what I would think is to multiply 2, 3, 4, 5, 8, and 9 together. But let's take note that 2 and 4 have a common factor of 2. So by multiplying 2 and 4, I will be finding a multiple that is larger than the lowest common multiple. Okay, so what I would do would be to list down 2, 3, 4, 5, 8, and 9. Okay, so let's find the common factor between some of the numbers. So I have 2 and 4 and 8 with a common factor of 2. So let me divide these three numbers by 2. I would have, okay, since 3 is not divisible by 2, I would just copy and paste 3 down. 4 is divisible by 2, so I'll have 2. 5 is not divisible by 2, I would bring 5 down. 8 divisible by 2, so I would have 4, okay, and 9 I'll bring it down. Okay, so next let's observe some of the terms. So I would focus on 2 and 4, so I realize that they have a common factor of 2. Alright, so I'll divide these two numbers by 2. The rest that are not divisible, I would just bring it down. So 1, 3, 5, and 9. Okay, so 2 is divisible by 2, I would have 1. 4 is divisible by 2, I would have 2. Okay, next let's look at 3 and 9. Both of them are divisible by 3, right? For the rest of the numbers, I will just copy them down. Okay, for 3 and 9, I will divide them by 3. I would have 1 and 3 respectively. Okay, so with these numbers, when I multiply them together, I would have the lowest common multiple between 2, 3, 4, 5, 8, and 9. Okay, my lowest common multiple would be 2 multiplied by 2 multiplied by 5 multiplied by 2 multiplied by 3, which gives me 360. Okay, the next part of the question says that it leaves a remainder of 5 when divided by 7. So when I have 360, okay, I take 360 divided by 7. Okay, this gives me 51, remainder 3. Okay, so remainder 3 obviously is not 5. How do I find the lowest number that gives me remainder 5? Okay, so when I multiply them by a certain number, I'm also multiplying the remainder, right? So next, we need to focus on the multiples of 3. So multiples of 3, I have 3, 6, 9, 12, so on and so forth. Okay, when I divide 9 by 7, I have 1, remainder 2. Okay, so this is also not the remainder I want. When I divide 12 by 7, I have 1, remainder 5. Okay, so 12 is the multiple of 3 that I am looking at. Okay, so to get 12, I multiply 3 by 4 times. So therefore, I take 360 multiplied by 4, and that would give me 1,414. Okay, so let's backtrack and check whether my answer is correct. So when I take 1440 divided by 7, I would have 205 remainder 5. Okay, so therefore X is 1440. Alright? Okay. So that is the answer for question 1, part B. Okay, next let's look at question 2. Question 2, they want us to simplify the following algebraic expression as a single fraction. Okay, right off the bat we see that this algebraic expression consists of 3 fractions. Okay, so by looking at our first fraction, we will realize that the denominator is a quadratic expression. Okay, that is a clue that we need to factorize this denominator. By looking at the next two, we realize that it's a linear equation. Okay, so I am hoping that when I factorize my first denominator, it would be a multiple of these two linear equations. Okay, so my first step would be to factorize. Okay, I will put negative y squared here, 2 here, and negative y here. Okay, factors of negative y squared, I have negative y and y. Factors of 2, I have 2 and 1. I need to take note that after adding my product, I should have negative y. Therefore, I will place my 2 here and I will place 1 here. This would give me y and negative 2y. When I add them together, I have negative y. Okay, so I can rewrite my expression as 4 divided by negative y plus 1 multiplied by y plus 2 plus 1 over 2 plus y minus 3 over y minus 1. Okay, by observation, I would realize that 2 plus y and y plus 2 is the same. Okay, but what's a little bit different would be negative y plus 1 and y minus 1. So even though the values of the terms are the same, but the sign in front of them is not the same. Okay, so how do I flip the sign? I can bring out my negative sign. Okay, so when I bring out my negative sign, what will I have? Let's say if I were to bring out my negative sign in my third term, I would have 4 over negative y plus 1 multiplied by y plus 2 plus 1 over 2 plus y minus 3 over negative 1 minus y. Okay, and when I bring up my negative sign, negative, negative, this gives me positive. Alright? Okay, with this, things are much simpler. I just have to come up with a common denominator. So when I come up with a common denominator, the first expression already has the lowest common multiple. Okay, for my second equation, I need to multiply 1 minus y in my numerator and my denominator. Okay, so I have 1 minus y over 1 minus y times y plus 2 plus, okay, for my third term, I have to multiply y plus 2 in my denominator and numerator. So 3 multiplied by y plus 2 over 1 minus y times y plus 2. Okay, so now since I have a common denominator, I can merge my 3 fractions together. In my denominator, I have 1 minus y multiplied by y plus 2. And in my numerator, I would have 4 plus 1 minus y plus 3 multiplied by y plus 2. Okay, so then my last step would be to simplify. To expand my brackets in my numerator, I have 5 minus y plus 3y plus 6 over 1 minus y times y plus 2. Okay, so that would give me 11 plus 2y over 1 minus y times y plus 2. Okay, and that would be your final answer for question 2, part A. Alright, next let's look at question 2, part B. Question 2 part B, they want you to simplify this expression as a single fraction. Okay, so many students, when they see this, they will become very excited and they will expand all of our brackets. But before we do that, let's see whether there is a way to simplify things first. Okay, by observation in my numerator, I will realize that there are 3 terms, right? I have 2a multiplied by a plus 1, I have 3b multiplied by a minus 1, and I have 5c squared multiplied by a minus 1. By looking at these 3 terms, do I have a common factor? I do. I have a common factor, a minus 1. So remember your factorization by grouping. Are you able to group a minus 1 together? Okay, so I can bring out my common factor a minus 1. Okay, what would I be left with? I will be left with 2a plus 3b plus 5c squared. Okay, this would be my numerator. Okay, for my denominator, before I even expand my square, let's see whether I can further simplify it. Okay, so when I observe, I have 2 terms. Alright, I have a term over here, 2a plus 3b squared. I have a term over here, 25c to the power of 4. The next thing I will realize is my first term is to the power of 2. Okay, my second term is to the power of 4. Alright, what can I do about this? Remember your algebraic identity. A squared minus b squared equals to a plus b multiplied by a minus b. Correct? In this case, your a would be 2a plus 3. Or 2a plus 3b. Okay? And in this case, your b, 25c to the power of 4 is b squared. I can rewrite this as 5 squared c squared squared. Alright? Okay, so this will simplify to 5c squared squared. Okay, so in this case, your b would equal to 5c squared. Okay, so with this, I can rewrite my denominator as 2a plus 3b plus 5c squared multiplied by 2a plus 3b minus 5c squared. Okay, when I observe my numerator and my denominator, do I see something in common? Okay, if I see here, these 2 terms are exactly the same. So that would mean that I can cancel them. Alright, so when I cancel, I would be left with a minus 1 over 2a plus 3b minus 5c squared. And this would be my final answer for question 2 part B. Alright, next let's look at question 3. Question 3 expects us to factorize completely. If we were to look at part A, we will realize that part A has 2 terms. Alright, 16x to the power of 4 minus 81y to the power of 8. Okay, when I look at these 2 terms, x to the power of 4 and y to the power of 8 is not a like term. So how do I factorize it, or how do I simplify it? So let's look at this. We realize that it's 2 terms. Okay, the relationship between them is subtraction. From what we have learned in algebraic identities, we know that a squared minus b squared equals to a plus b multiplied by a minus b. Alright, okay, so my next step or my next goal is to express 16x to the power of 4 in terms of a square and 18y to the power of 8 in terms of square. Okay, 16 I know that is 4 to the power of 2. X to the power of 4 I know that is x squared to the power of 2. Alright, 81 I know that it's 9 to the power of 2. And y to the power of 8 I know that it's y to the power of 4 to the power of 2. Okay, so from here I can further simplify my expression. I have 4x squared to the power of 2 minus 9y to the power of 4 to the power of 2. Okay, from here, I know that in this case, my a is 4x to the power of 2, and my y is, and my b is 9y to the power of 4. So I can factorize it to be 4x squared plus 9y to the power of 4 multiplied by 4x squared minus 9y to the power of 4. Okay, for this expression over here, I cannot further simplify it. But if I were to look at my second bracket, I'll realize that it's the same case. I also have a squared minus b squared in my second bracket. But in this case, it would be 4, I can express it as 2 to the power of 2. And 9, I can express it as 3 to the power of 2. Okay, and y to the power of 4, I can express it as y squared to the power of 2. So therefore, I can further simplify this as 4x to the power of 2 plus 9y to the power of 4 multiplied by, so in this case, my a would be 2x and my b would be 3y squared. So I have 2x plus 3y squared multiplied by 2x minus 3y squared. Okay, so when I look at this, I realize that I cannot further factorize. So this would be my complete factorized form. Alright, and that would be my answer for part A. Okay, next let's look at part B. Part B, I have something that is not commonly seen. Okay, if I were to rewrite this expression, maybe I would bring my 12xy forward. Okay, so I have 4x squared plus 12xy plus 9y squared minus 36. Okay, does this look very familiar? It does. Okay, because we have learned the algebraic identity a plus b squared equals to a squared plus 2ab plus b squared. Alright, so in this case, if I were to express 4x squared in terms of a complete square, I would have 2x to the power of 2. Okay, and if I were to express 9y squared in the form of a complete square, I would have 3y to the power of 2. By observation, do you realize that 12x squared is actually 2 multiplied by 2x multiplied by 3y? So from here, I can factorize this using my algebraic identity as 2x plus 3y squared. Okay, because in this form, I can see very clearly that my a is 2x and my b is 3y. Okay, so this would mean that I can further simplify my expression as 2x plus 3y squared minus 36. Okay, from here, the question expects you to know that 36 is a complete square. Okay, so this expression can be written as 2x plus 3y squared minus 6 squared. So then again, we come back to the algebraic identity. A squared minus b squared equals to a minus b multiplied by a plus b. Alright, and in this case, a is 2x plus 3y and b is 6. Okay, so I can further express this as 2x plus 3y plus 6 multiplied by 2x plus 3y minus 6. And this would be my complete factorized form. Okay, so that would be my answer for question 3 part B. Next, let's look at question 4. Question 4 wants us to solve the following equation. So if you realize, we would have 2 fractions on our left side and 2 fractions on our right side, okay, with different denominators. But our denominators are all numericals, so it would be easy for us to find the common denominator. To find the common denominator, we would just have to find the lowest common multiple of 3, 4, 2, and 6, which is 12. Alright, so let's express our fraction with the denominator as 12. Okay, so for 3, if I want to turn it into 12, I need to multiply by 4. if I multiply by 4 in my denominator, I need to multiply by 4 in my numerator. For our second fraction on the left, to turn 4 into 12, I need to multiply by 3. Okay, so when I multiply by 3 in my denominator, I need to multiply by 3 in my numerator. And on our left hand side, to turn 2 into 12, I need to multiply by 6. When I multiply by 6 in my denominator, I need to multiply by 6 in my numerator. And lastly, to turn 6 into 12, I need to multiply by 2. So when I multiply by 2 in my denominator, I need to multiply by 2 in my numerator. Our next step would be to merge our fractions. So we have 4 multiplied by 3x minus 5 minus 12 multiplied by 2x plus 5 over 12 equals to 18 multiplied by 6x minus 1 plus 6 multiplied by 9x plus 1 over 12. Okay, so from here we actually can multiply 12 throughout the entire equation to remove our fraction. Okay, so that is what I'm going to do. So I would have 4 multiplied by 3x minus 5 minus 12 multiplied by 2x plus 5 equal to 18 multiplied by 6x minus 1 plus 6 multiplied by 9x plus 1. And my last step would be to open up my brackets and simplify. So let's do it one step at a time. When I open up my bracket, I would have 12x minus 20 minus 24x minus 60. So this would equal to 108x minus 18 plus 54x plus 6. Alright? Okay, before I even move any of my terms, let's simplify both sides first. Okay, so I have 12x minus 24x, that will give me negative 12x. Negative 20 minus 60, I have negative 80. Alright, 108x plus 54x, that would give me 162x. Okay, and negative 18 plus 6, that gives me negative 12. Okay. Okay, from here, I would isolate all of my terms with x on one side and my numericals on the opposite side. Okay, so I would bring my negative 12x to the right hand side. Okay, to do that, I need to add 12x on my left hand side and add 12x on my right hand side. Okay, this 12x minus 12x will cancel out. Okay, I would have negative 80 equals to 174x minus 12. Okay, to isolate all of my numericals to one side, I would add 12 to my right hand side. Okay, when I add 12 to my right hand side, I need to add 12 on my left hand side. Alright, negative 12 minus 12 on my right hand side cancels out. So that would leave me with negative 68 equals to 174x. Okay, so to find x, I just have to divide 68 by 174, and that leaves me with negative 34 over 87, which is my final answer. Alright, next let's look at question 5. Question 5, they want us to simplify the algebraic expression. So even before we even start to do anything, let's study what we have, okay? When I look at this expression over here, I have x squared minus y squared. So when you see something like that, your alarm bells should ring. You should recall the algebraic identity a squared minus b squared equals to a plus b multiplied by a minus b. Okay, and when I look at my expression here, I have a mixture between x squared, 2x, xy, and 2y. So what can I do about this? Okay, maybe I can try factorization by grouping. So when I look at factorization by grouping, so x squared minus y squared, that will give me x plus y multiplied by x minus y over x plus y. Okay? For my x minus y, I would retain it. Okay? Let's try factorization by grouping in my denominator of my second term. So when I factorize out x, I have x plus 2. For my second term, I will factorize out negative y. Okay? And that will give me x plus 2. Okay, so when I studied this expression, I will realize that I have a common factor of x plus 2. And that would mean that I can factorize this out. Okay, let's work with this. So I will copy and paste my first term. Okay, for my second term, let's factorize our x plus 2. So I would have x plus 2 multiplied by x minus y. Okay, let's look at what we have. For my first term, I have x plus y as a factor in my numerator. I have x plus y in my denominator. For my second term, I have x minus y in my numerator. I have x minus y as a factor in my denominator. Okay, so with this, am I able to cancel out some terms? I could. Okay, so I could cancel out x plus y. I can cancel out x minus y. So what would this leave me with? I would have x minus y multiplied by 1 over x plus 2. Okay, if I were to express it as a single fraction, I would have x minus y over x plus 2, which is my final answer. Alright, okay, so this is the answer for question 5 part A. Let's look at question 5 part B. For this question, they again want us to simplify the algebraic fractions, but instead of having multiplication, we have division. Okay, let's not panic. So the first step when you see division, we want to express them as a single fraction. So for my first expression, when I want to add an n in my denominator, so I need to multiply. N can be expressed as n over 1. Okay, when I want n in my denominator, I can multiply n in both my numerator and denominator. The next one, so I have 11 over 1. When I want n in my denominator, I can multiply n in my numerator and denominator. So this is the same for 2n. So 2n also can be expressed as 2n over 1. When I want my denominator to be 1, I can multiply by n in my denominator and numerator. Okay, since 15 over n already has a denominator of n, I will leave it like that. Okay, so when I simplify my expression, what do I have? I have n squared over n minus 9 over n divided by 11n over n minus 2n squared over n minus 15 over n. Okay, let's simplify what I have. I have n squared minus 9 over n divided by 11n minus 2n squared minus 15 over n. Okay, so what is a rule we have learned with division? When I divide something by a fraction, I can change it to multiplication sign. But what happens to my fraction afterwards? I flip my fraction, right? So I have n over 11n minus 2n squared minus 15. So with this expression, do realize we have something similar in our numerator and denominator. Okay, so this is a clue that we can cancel it out. We can simplify this as n squared minus 9 over 11n minus 2n squared minus 15. Okay, is this our final answer? No, not true. Why so? Because if we look at this, remember, I have mentioned that if we see something like that, our alarm bells should ring. It should remind us of our algebraic identity. A squared minus b squared equals to a minus b times a plus b. Okay, and with this I have a quadratic equation, so I can try cross factorization. Okay, so let's do a cross factorization over here. I have negative 2n squared, I have negative 15 and negative 11n. Okay, so I'll split this as 2n and n. Okay, I want a difference of 11n. I want a difference or an addition of 11n. So I can split 15 into 3 and 5. So 5 multiplied by n gives me 5n. 2n multiplied by 3 gives me 6n. Okay, numerically speaking, 5n and 6n, yes, I get 11n. But I want a negative. So which means that I should have negative 5n and negative 6n. Okay, let's look at our fraction. Let's look at our terms again. I have negative 15. Alright, so that would mean that I can place a negative sign either in front of my 5 or my 3. Okay, and that would also mean that I can place a negative sign in front of 2n or n. Okay, but here comes the trick. If I place my negative sign in front of my 3, I cannot place my negative sign in front of 2n. I need to place it in front of n. Vice versa. Okay? So with this, we have factorized both our numerator and denominator. For my numerator, I have n plus 3 multiplied by n minus 3. For my denominator, I have 2n plus 5 over negative n minus 3. Okay, so by studying what we have, we realize that we have something very similar in our denominator and numerator. But something is wrong. The term is different, right? For here, I have negative n minus 3. So I cannot just cancel it out. But what about if I factorize out my negative 1? Okay, so I have n plus 3 multiplied by n minus 3 over negative 2n plus 5 multiplied by n plus 3. So with this, I can safely cancel out n plus 3, and that leaves me with my final answer, n minus 3 over negative 2n minus 5. Okay, if I want to express this cleaner, I can factorize negative sign in both denominator and numerator, and that would leave me 3 minus n over 2n plus 5, which is my final answer. Alright, let's look at question 6. Question 6 requires us to make the letter in the brackets as the subject of the formula. So if we look at question 6 part A, they require us to make Q the subject. Okay, if I observe the expression, I realize that Q is here, which is in a square root. Okay, so this is something that I need to take note. First, I want to remove the square root. So when I remove the square root, what I do is I square both sides. Okay, and that would give me 16a squared equals to b over q squared minus 2 over 3c. The next thing I need to do is to isolate the term with q. Okay, so the term that I'm looking at right now would be this term over here. Okay, so I would aim to move 2 over 3c to the left hand side. Okay, so if I want to move 2 over 3c to the left hand side, I just add 2 over 3c to both sides. Okay, and that would give me b over q squared equals to 16a squared plus 2 over 3c. Okay, the next thing I can do is let's try and simplify this expression that I have on my right hand side. Okay, maybe I'll merge the two of them into a single fraction. I would have 16a squared multiplied by 3c over 3c plus 2 over 3c. So this would give me 48a squared plus 2 over 3c. Okay, the next thing I can do is I can cross multiply. Okay, Okay, so when I cross multiply, I take b multiplied by 3c equals to q squared multiplied by 48a squared plus 2. Alright, that would give me q squared multiplied by 48a squared plus 2 equals to 3bc. So to isolate out q, I have q squared equals to 3bc over 48a squared plus 2. Okay, and my last step would be to square root both sides. Because I have q squared, I want q. So when I square root both sides, I would have q equals to plus minus square root 3bc over 48a squared plus 2. Okay, which is my final answer. Alright. Okay, this is the answer for question 6 part A. Let's look at question 6 part B. Question 6 part B requires us to make y the subject of the formula. Okay, if I were to observe what I have in this expression, let me find my y. My y, I have it here. My y, I have it here. My y, I have it here. Okay, so all three terms have y. What do I do? Okay, I'll realize that this expression is a mixture of fractions and whole numbers. Okay, so first let's try and express this as one layer of the equation. So I will merge my two fractions. Okay, so I will have 3x multiplied by 4yz minus 3w squared over 15 minus 5y over 15 equals to 12y. So what I can do next is to multiply 15 throughout the entire equation. So that would give me 3x multiplied by 4yz minus 3w squared minus 5y equals to 180y. Okay, with this, let's simplify my expression first. Okay, if I open up my bracket, I would have 12xyz minus 9xw squared minus 5y equals to 180y. Okay, my next step would be to isolate all of the terms with y on one side. So if I observe, I would have three terms with y. Okay, so let's move all of these three terms to one side. Okay, I would have 12xyz minus 5y minus 180y equals to 9xw squared. Okay, what's my next step? I would realize that all of my three terms are a multiple of y. What can I do? I can factorize out my y. Okay, so when I factorize out y, I would have 12xz minus 185 equals to 9xw squared. Okay, so to find my expression in terms of y, I would take 9xw squared over 12xz minus 185. Okay, and this would be the final answer. Alright? Okay, next, let's look at question 7. Question 7 says if 3x minus y over 2x plus 3y equals to 2 over 3, we want to find the value of x over y. Okay, so we need to keep in mind for this question, they are not requiring us to solve for x and y. We just want to find the relationship between x and y. Okay, let's work with our first fraction first. Let's simplify this so that it's easier for us to digest the information given. Okay, when I have two fractions on the left hand side and on the right hand side of my equal sign, the first thing I want to do is to cross multiply. Alright, so when I cross multiply, I would have 3 multiplied by 3x minus y equals to 2 multiplied by 2x plus 3y. Okay, so this gives me 9x minus 3y equals to 4x plus 6y. Okay, let's isolate out x and y. Okay, so I would want all of my terms with x on one side of my equation. I want all of my terms with y on the other side of my equation. Okay, let's work this out step by step. So first I want to minus 4x on both sides. Okay, and that would give me 5x minus 3y equal to 6y. Okay, my next step would be to add 3y on both sides. Okay, and this would give me 5x equals to 9y. Okay, so can I find x over y? I could. So x would equal to 9 over 5y. So x over y would equal to 9 over 5, which is the answer for question 7. Okay, x over y is 9 over 5. Alright, let's move on to question 8. Okay, question 8 is an algebra question. Okay, let's read the question together. They say Janet bought some packets of ties and socks. The ties are packed in 2 per box, while the socks are packed in 2 pairs per box. Okay, she counted 70 boxes and 176 items in all. Okay, so a pair of socks is counted as 2 items. Let's be the number of boxes of ties Janet bought. Okay, express in terms of x the number of boxes of socks Janet bought. If Janet bought x number of boxes of ties and there are 70 boxes in total, the number of boxes of socks would be 70 minus x. Alright. Okay, so for part B, they want me to form an equation in x and solve it to find the number of ties Janet bought. Okay, what do we know? We know that there is a total of 176 items. Okay, and the question already told us that Janet has x boxes of ties, right? And each box of tie, there is 2 ties. So I have 2 multiplied by x number of ties. Okay, which is 2x ties. Okay, I know I have 70 minus x boxes of socks. And I know that in each box of socks there are 2 pairs, which means there are 4 socks, right? So how many socks do I have? I have 4 multiplied by 70 minus x socks. Okay, if I were to simplify this, I would have 280 minus 4x socks. Okay, and in total, ties and socks, I have 176 of them. So when I add 280 minus 4x plus 2x, this should give me 176. Alright, so this is the equation that we have formed. Next, we want to solve for x. Alright, so to simplify my equation, this would give me 280 minus 2x equals to 176. Therefore, 2x would equal to 104 and x would equal to 52, which is my final answer. Alright, let's look at question 9. So question 9 requires us to solve the following inequality. Okay, so for part 1, we have 3 fractions. Of course, we want to eliminate the fractions. So I will multiply by the lowest common multiple between 7, 5, and 3, which turns out to be 105. Okay, so when I multiply 105 throughout the entire equation, I would have 15 multiplied by 2x minus 3 minus 21 multiplied by 4, which gives me 84 multiplied by 2 minus 3x is more than or equal to 70x plus 105. Okay, all right. So from here, let's simplify the expression. So I will have 30x minus 45 minus 168 plus 252x is more than or equal to 70x plus 105. Okay, before I even move any of my terms, let's simplify them to the simplest form first. Okay, so I have 285x minus 213 is more than or equal to 70x plus 105. Okay, so let's shift the terms around where I want to isolate the terms with x on one side. Okay, so I'll move 70x from the right hand side to the left hand side. That would leave me with 215x is more than or equal to 318. Okay, so with this, then I can just divide both sides by 215, where I would have x would be more than or equal to 1.5. Okay, which is my answer for question 9 part 1. Let's look at question 9 part 2. Okay, where I have something similar, but now I have two inequalities equation. Okay, so my first step would be to split my inequality equation. So I have 4 plus 9x is less than 2 multiplied by 2x minus 5, and 2 multiplied by 2x minus 5 is less than or equal to 1 over 3 multiplied by 2x plus 5 minus 1. Okay, so from here, let's work each of the equations separately. Okay, I would have 4 plus 9x is less than 4x minus 10. So 9x is less than negative 14. All right, 5x is less than negative 14. So x is less than negative 4 over 5. Okay, let's work with this equation. I would multiply by 3 throughout the entire equation just to eliminate my fraction. Okay, so I have 6 multiplied by 2x minus 5 is less than or equal to 2x plus 5 minus 3. Okay, let's expand and simplify our equation first. I would have 12x minus 30 is less than or equal to 2x plus 2. Okay, so that would give me 10x is less than or equal to 32. So x is less than or equal to 3.2. Okay, so now I have two inequalities where x can be a range of values. What I need to do is to represent these two inequalities on a number line and find out the part that overlaps with each other. Okay, so if I were to draw a number line, I will mark out my positive 3.2 and my negative 2/4/5. Okay, to represent the inequality x is less than negative 2/4/5, I will have a hollow circle going in this direction. To represent x is less than or equal to 3.2, I would have a solid circle going in the same direction. So what overlaps would be this part over here, which means my final answer should be x is less than negative 2 and 4/5, which is the answer for question 9, part A, part 2. Alright, let's move on to question 9, part B, part 1. We have this. So if x is between 2 and 5 and y is between negative 3 and positive 1, we want to find maximum and minimum value of this equation. Okay, so before we even start anything, let's look into what possible values x and y could be. Just by looking at this range, I'll realize that x is always positive, okay? And y is, it could be negative, it could be positive. Okay, so if I want to find maximum value of 3x minus 2y squared, okay, so this needs to be the largest and this needs to be the smallest. Okay, there is a case where 2y squared is negative, then minus negative I get positive. But let's look at 2y squared. Y squared will always be a positive value. So in this case, I want to make sure that my 2y squared, the second part of my equation, is the smallest value possible. Okay, so to maximize 3x, of course, I take the largest number of 3, which is 3 multiplied by 5. Okay, and to minimize 2y squared, I would take the smallest value. Alright, so in this case, the smallest value would be 0. Okay, because y ranges from a negative value to a positive value. Okay, so I would have minus 2 times 0 squared. So this will give me 15, which is the maximum value of 3x minus 2y squared. Okay, and let's look at minimum value. So again, minimum value, if this is positive, alright, so I want to make this as large as possible. Okay, and I want to make this as small as possible. Okay, so I'll choose the lowest value of x, which is 2. Okay, and I would choose the largest value, the largest numerical for y. Okay, I know that 1 is larger than negative 3. But if we were to just look at the numerical value, 3 and 1, which one is larger in size? Of course 3, right? So I would choose 3. Because of the square, I am eliminating the negative sign. Okay, so what this gives me will be 6 minus 2 times 9. Okay, so 6 minus 18, which equals to negative 12, which is the answer for question 9 part B part 1. Let's look at question 9 part B part 2. I want to find the maximum and minimum value of this over here. Okay, so for maximum value of y over x minus 1 over x squared. Okay, if we were to analyze this, okay, if I want to find maximum value, of course this must be the largest, but it must be positive. Okay, and this must be the smallest. Okay, and since x squared is a positive value, we want it to be the smallest one. Alright, okay, how do I get the largest positive value of y over x? Okay, I want to keep y as small as possible. Sorry, I want to keep y as large as possible. I want to keep x as small as possible. Okay, but am I looking at the numerical, the number, or am I considering the value of the number? Okay, in this case, I need to consider the value of the number because x is always positive. So if I have a negative value of y, my entire fraction will be negative. So that is working against what I want, right? Okay, so I would choose the largest value for y, which is 1 in this case, okay, and the smallest value of x, which is 2 in this case, okay. And if I want 1 over x squared to be as small as possible, I want to maximize my numerical, I want to minimize my denominator. Sorry, if I want to make 1 over x squared as small as possible, I want to minimize my numerator, I want to maximize my denominator. Okay, in this case, numerator is fixed. I can only change my denominator. I will make sure that my x squared is as large as possible. Okay, largest. Okay, so I would choose the largest value of x, which is 5. Okay, and this I would have half minus 1 over 25. Okay, this would give me 25 over 50 minus 25 over 50 minus 2 over 50. So that would give me 23 over 50. Okay, which is my answer. Alright. This is the maximum value. Let's look at minimum value. Okay, if I want it to be as small as possible, that would mean that I want this to be as large as possible. Okay, if I want this to be as large as possible, my denominator should be as small as possible. Okay, and of course, I want my y minus x to be as small as possible. Okay, if I want my y over x to be as small as possible, I would. Okay, in this case, because I can play with the signs, right? My y could be positive or negative. If I want it to be as small as possible, I would take y to be a negative value. Okay, if y is a negative value, then I want the numerical to be as large as possible. Okay, so if the numerical is as large as possible, as long as my y over x is negative, how do I go about doing this? If I want my fraction to be as large as possible, I would make my y to be the largest in numerical, in number, alright? And my y to be the smallest. Okay, so in this case, I would choose negative 3 for my y, and for my x, of course, I would choose 2. Okay, minus 1 over 2 squared. Okay, and that should give me negative 1, 3 over 4, which is my answer for question 9, part B, part 2. Okay, next, let's look at question 10. A survey was conducted to find the number of siblings each group of students has. The results are shown below. If the median is 3, alright, find the largest possible value of x. Okay, if I want my median to be 3, that would mean that there is the same number of people here and the same number of people here. Okay, so let's say I have 4 students with 3 siblings. Let's say the median is this student over here, just to maximize my value of x. Okay, so my largest possible value of x would be 3 plus 7 plus x equals to 3 plus 6 plus 8. Alright, so x would equal to 17 minus 10, which is 7. Okay, I want to find the smallest possible value of x. Okay, so again, there are 4 people here with 3 siblings. If I want the smallest possible value of x, that would mean that the last student over here is the median. So there is the same number of students here and here. Alright, so 3 plus 7 plus x plus 3 equals to 6 plus 8. So 13 plus x equals to 14, x equals to 1. Alright, okay. Now let's look at question 10, part B. If the mode is 2, write down the smallest possible value of x. If the mode is 2, mode is the student with the highest frequency, right? So it cannot be any smaller than 8. Therefore, x should be 9. Okay. If we look at part C, if the mean number of siblings is 2.9, find the value of x. How do I find mean? Okay, I take the total number of siblings they have divided by the total number of students. So I have 3 multiplied by 0 plus 7 multiplied by 1 plus x multiplied by 2 plus 3 multiplied by 4 plus 4 multiplied by 6 plus 5 multiplied by 8 divided by the total number of students, which is 3 plus 7 plus x plus 4 plus 6 plus 8. This equals to 2.9. Okay, if I were to simplify it, okay, I would have 7 plus 12 plus 24 plus 40 plus 2x equals to 81.2 plus 2.9x. Okay, so 0.9x will equal to 1.8, therefore x would equal to 2. To question 11. Okay, question 11, they want us to find the value of x and y in the following figure. Okay, I have a pair of parallel lines A, B, and C, D. But there is no straight line that links my two parallel lines together. Okay, so what I can do is I can add my own parallel line and let me name it as H and I. Okay, so if I were to highlight it, I have 3 parallel lines. Okay, and if I were to annotate, I will realize that angle BEF would equal to angle EFH. So this angle over here would equal to this angle over here. Okay, why? Because they are alternate angle where AB is parallel to HI. The next thing I can take note is angle DGF equals to angle HFG. Okay, so if I were to annotate, this angle over here would equal to this angle over here. Okay, why is it so? Because again they are alternate angle where HI is parallel to CD. Okay, so what can I say? Angle EFG equals to x plus 10 degree plus 3x degree. Okay, and also it equals to 84 degrees. So let's solve for x. Okay, I have x plus 10 plus 3x equals to 84. 4x equals to 74. So x would equal to 18.5 degree. Alright? Okay, if I know that x equals to 18.5, okay, what else can I make use of, okay, in terms of y? Do you agree that angle AEF plus angle HFE equals to 180 degrees? So the green angles would add up to 180 degrees. Okay, why is this so? Because they are interior angles where AB is parallel to HI. Okay, and I know that angle HFE is the same as angle BEF, which is x plus 10, which is 18.5 plus 10. Okay, so I can rewrite my expression as y plus 28.5 degrees equals to 180. Okay, so y would equal to 180 minus 28.5 degrees, which is 151.5 degrees. Okay, alright. Okay, let's move on to part B. In the figure below, we have 2 pairs of parallel lines. Okay, we know that obtuse angle DCB is 192 and angle NFG is 56, angle CBA is 17. They want us to find angle X. Alright, so again, we realize that we have a few pair of parallel lines, but there are not a lot of straight lines that link my parallel lines together. Okay, so why not we create our own lines that are parallel? So I would join one line over here and one line over here, where these 2 lines are parallel to EG and AB. Okay, let's name these points as W, X, Y, Z, for example. Okay, so what can I find? Alright, first, I know that this angle over here is the same as this angle over here. Okay, so let me just write that down. Angle NFG equals to angle EFM, okay, which is 56 degrees because they are vertically opposite angles. Alright, okay, angle EBX equals to angle EFM, which equals to 56, okay, because they are opposite angles of a parallelogram. Alright, so if I were to annotate, this angle over here also equals to 56. Okay, so what we are missing is this angle over here. Agree? Okay, so by studying this, I will realize that this angle over here is the same as this angle over here. Okay, which is part of my 192. So I want to find angle YCB, but I want to find angle YCB first in order to find my orange angle. Okay, so to find angle YCB, I know that angle YCB plus angle CBA equals to 180. Okay, why is this so? Because they are interior angle, where YZ is parallel to AB. Okay, so angle YCB would equal to 180 minus 17, and that would give me 163. Okay, so angle YCD would equal to 192 minus 163, which equals to 29 degrees. So therefore, angle X, which is made up of angle EDX plus angle YCD, and this equals to 56 plus 29, which gives me 85 degrees. Okay, so therefore X would be 85 degrees. Okay, and that is my answer for question 11. Alright, let's look at question 12. The figure shows a square ABCD and an equilateral triangle ABE. Okay, they want us to find angle CED. So they would want us to find this angle over here. Okay, before we even start, let's annotate the diagram. If it's an equilateral triangle, it will mean that this side is the same length as this side, which is the same length as this side. Okay, and all of the angles are 60 degrees. Okay, and if it's a square, it would mean that all four sides are the same length. Okay, so that would mean that AB equals to AD equals to DC equals to BC. Okay, so I can do this. Okay, and just by looking at this, we will realize that triangle ADE and triangle BEC is an isosceles triangle. That would mean that these two angles are the same. Okay, and these two angles are the same. Okay, and since all sides of the square is 90 degrees, that would mean that this is 30 degrees. That would mean that this is 30 degrees. And this is 30 degrees. Okay, so with this, we will be able to find the green angle and the yellow angle, and hence we can find the red angle. Okay, so we know the train of thought of how to solve this question. Let's pen it down to explain how we can solve it. Alright, so angle AEB equals to angle ABE equals to angle BAE, which is 60 degrees because they are isosceles triangle. Equilateral triangle. Alright, okay, and then angle ABE angle DAE would equal to 90 minus 60 degrees, which gives us 30 degrees. Explanation, angle in a square, right? Okay, and then angle AED would equal to 180 minus 30 divided by 2. Why? Because angle in isosceles triangle. Alright, and that would give me 75 degrees. Okay, alright. So therefore, angle CED would equal to 360 degrees minus 75 degrees minus 75 degrees minus 60 degrees, which gives us 150 degrees. Okay, which is the final answer. Okay, we need to explain why we take 360, because they are angles at a point. Alright, okay. So this is the answer for question 12, part A. Let's look at question 12, part B. In the diagram ABCDF is a hexagon. The straight line BAG is parallel to DE. So let's annotate. Okay, so this is parallel to this. Okay, AFE is 90 degrees. So this is 90 degrees. Okay, and FAG is 55 degrees. Okay, and they want me to find angle FED. So they want me to find this angle over here. Okay, so to find this right angle over here, I have a pair of parallel lines, but again, there are no straight line that joins these two parallel lines. So of course, I would want to add my own parallel line through F. So if I add my own parallel line through F, let me name this as PQ. Okay, I know that angle AFAG would equal to angle AFP, because they are alternate angle where AG is parallel to PQ. Okay, from here we can find angle PFE, because I just have to take 90 degrees minus 55 degrees, and that gives me 35 degrees. Okay, and I know that angle PFE plus angle DEF equals to 180 degrees. Why? Because they are interior angle where PQ is parallel to DE. Okay, so that would leave me as angle FED equals to 180 minus 35, and that leaves me with 145 degrees, which is my answer for part 1. Then let's look at part 2. Show with reason that ABC plus BCD plus CDE equals to 360 degrees. Okay, so that is not very hard. Let me erase my working for part 1. I will annotate the final answer beside the question. Okay, so since we already know angle FED, we know angle AFE, and we are able to find angle VAF, it is not hard to prove that the addition of the rest of the angles adds up to 360 degrees. First, what do? We find sum of interior angle. Okay, so it is a hexagon, it has 6 sides. Sum of interior angle would be given by 6 minus 2 multiplied by 180 degrees, and that would give me 700. That would give me 720 degrees. Okay, we are able to find angle BAF by taking 180 minus 55. Okay, which gives me 125 degrees. Why? Because they are angles on the straight line. Alright, so angle ABC plus angle BCD plus angle CDE plus 125 plus 90 plus 145 equals to 360. equals to 720 degrees. Okay, so angle ABC plus angle BCD plus angle CDE would equal to 360 degrees. Okay, therefore shown. Alright. Okay, so that is the answer for question 12, part B, part 1 and 2. Alright, lastly, let's look at question 13. An alloy A contains zinc, tin, and in the ratio of 5:2 by weight. Another alloy B contains copper and tin in the ratio of 7:3 by weight. So they are asking to find the weight of zinc required to make 350 kg of alloy A. Okay, so we can see this as 350 kg would be 7 units, right? So to find the weight of zinc, it would be 5 units out of the 7 units. So it would be 5/7 multiplied by 350. So that would give me 250 kilograms. Okay, then for part B, find the ratio of zinc, tin, and copper in the new alloy containing equal weights of A and B. So if it is equal weight of A and B, okay, so I would have the ratio of zinc is to tin as 5:2, and the ratio of copper is to tin is 7:3. If I want them to be the equal weight, this would mean that I need to find a common factor between the total weight of alloy A and alloy B. Okay, so total weight of alloy A as of now is 7 units. Total weight of alloy B as of now is 10 units. So the lowest common multiple would be 70. Okay, so I need to multiply by 10 for the ratio of my alloy A, where I will have 50:20. Okay, and I need to multiply by 7 to the ratio of alloy B, so I will have 49:21. Okay, so now my total units for both alloy A and alloy B is the same. I can merge my two ratios together. Okay, so I have zinc is to tin is to copper. It should be 50:41:49, which is the ratio. Okay. Next, let's look at question 13, part C. Tin is reported from Malaysia at a price of 29.1 ringgit per kilogram. An additional 8% tax is imposed on the purchase. The exchange rate between dollars and Malaysian ringgit is $100 is to 227 ringgits. Calculate the amount of Singapore dollars required to purchase 500 kilograms of tin from Malaysia. Okay, giving your answers correct to the nearest dollar. So for part C, first of all, I need to find the cost of tin in Malaysia. Okay, so the cost of tin would be given by 29.1 multiplied by 500. Okay, that is the cost. But let's not forget that there is an 8% tax. Okay, so I need to add on the 8% tax, so I need to multiply by 108%. Okay, and that would give me 15,714 ringgit. Okay, then I need to convert this to Singapore dollars. So previously I know that 227 ringgit is converted to 100 Singapore dollars. Okay, so to find how much is 15,714 ringgit, I take $100 divided by 227 multiplied by 15,714 okay, and that would give me Singapore dollars 6,922.47. Approximate to nearest dollar, I would have $6,922. Okay. Alright, then let's look at part D. 45% of the total expenses for producing the new alloy are for the cost of materials, 305 for wages, and the remainder for overheads. So in 2005, the total expenses was 925,000. Calculate the cost of overheads in 2005. Alright. Sorry. There is a mistake there is a typo for this. This should be 30% for wages. Okay, remainder for overheads. Total expenses was 925,000. So for overheads, it would take 100% minus 45% minus 30%, which is 25%. Okay, so 25% of this 925,000 is for overheads. So to find overheads, I just have to multiply 25% to the total expenses, where I would have 231,250. So this is the cost of overheads. And for part 2, the cost of wages in 2005 was 20% greater than that in 2004. So calculate the total cost of wages in 2004. Alright, so first of all, I need to find the cost of wages in 2005, where I take 30% multiplied by 925,000. Okay, that would give me 277,500. Okay, and as compared to 2005, there is a 20% increase in 2004. So to find the cost of wages in 2004, I would take 120% multiplied by 277,500. Okay, and that would give me 231,250. So that is the total cost of wages in 2004. Alright. Okay. So we have come to the end of our Sec 1 mock exam paper. I hope you have understood my explanation for all of the questions. If you have any questions, feel free to WhatsApp us. Okay, if you have any queries, also feel free to WhatsApp us. I hope I'll see you again. Bye bye. Thank you.